Why does the Earth, which weighs 600 billion tons, hover in space without falling down? Is there any mysterious force pulling it? You should know that in the universe, there is no distinction between up and down, and there is no so-called end. Even if you move in any direction, you will only move forward, without a break, and you will never hit the air wall. If so, why does the Earth not fly around in the universe, but stay in the solar system? Because the Sun has dug an invisible pit, and the Earth has been in this pit for 4.6 billion years. This is Einstein's space-time bend, a theory that is crazier than Newton's absolute space view. As early as 300 years ago, when Newton was hit by an apple, he found that since all things on Earth always fall down, instead of flying to the sky, it means that there must be a force pulling them, and this is the gravity of the Earth. According to the definition of gravitational force, all objects in the universe are attracted to each other. The higher the quality of the object, the greater the gravitational force. For the Earth, due to the influence of the gravitational force of the Sun, it circulates around the Sun in an elliptical orbit. But Newton never told us what the gravitational force is, and why it can interact with each other. This problem has troubled physicists for more than 200 years. Until 1915, Einstein proposed the relativity theorem. He thought that the so-called gravitational force did not exist at all, but that space-time had a bend. To better explain this phenomenon, suppose we put a heavy object in a tight log. We will find that the original flat log starts to bend down and twist the surrounding compact shape. This will make the orbit of small quality objects deviate. Because the quality of the Sun is 330,000 times that of the Earth, from the side, it presses the surrounding space-time out of a huge curve, and the Earth is like that little ball circling around the curve. So the Earth is not attracted by the gravitational force of the Sun, but is sliding in a curved space-time. At the same time, Einstein also proposed a more shocking conclusion, because all large quality celestial bodies in the universe twist the surrounding space-time, so the light will bend. This is the relationship between the Earth and the Sun. Because there is no friction resistance in the space-time, only when the Earth maintains a rotation speed of 29.8 kilometers per second can it keep sliding around the curvature of space-time of the Sun. Once the speed is too fast, it will be thrown out of the solar system. Too slow, it will hit the Sun. In fact, Newton described this phenomenon in a thought experiment more than 300 years ago. Suppose we hit a bomb on the top of the mountain. The distance of its landing depends on the initial speed of the bomb. As the speed of the bomb increases, the landing point will become farther and farther. By calculation, it can be obtained that when the initial speed of the bomb is maintained at 7.9 kilometers per second, and when it is accelerated by gravity by 9.8 meters per second, and the curvature of the surface of the Earth, the landing point of the bomb will become infinitely far. In the end, it will keep circling around the Earth and do the circular motion of gravity. It will never fall back to the Earth. This is the origin of the first speed of the universe, and the principle of the Earth's rotation around the Sun. In this case, where did the initial speed of the Earth come from? That is to say, even the light emitted from the Earth cannot move in a straight line in the universe, but will be bent by the curvature of space-time. This statement shocked the entire physics world at the time, because this statement was too absurd. To verify this view, in 1919, British astronomer Eddington found that the rotation angle of the light passing through the Sun was 1.61 plus or minus 0.3 micros. This means that the light emitted by the star far away did indeed bend near the Sun, which confirmed Einstein's general relativity that space-time can really be bent, and the gravitational force we thought was just an illusion, twisted by space-time. But the question is, why can the Earth keep sliding around the curvature of space-time of the Sun, but not fall into the Sun? The secret behind this is hidden in the initial speed of the Earth, or in the experiment just now. When we add a speed to the ball, we will find that when the ball is greater than the escape speed, it will run in a non-contracted orbit until it rolls out of the plane, and when it is less than the escape speed, the ball will follow the elliptical orbit. To figure out this problem, according to the current star theory model and the simulation results of a large number of computers, the solar system that was born about 4.5 billion years ago is called nebula. In this primitive nebula, there are a lot of high-temperature gases and particles. As the remaining sea of the nebula gradually shrinks, and under the effect of the gravitational conservation law, the speed of rotation is getting faster and faster. In the end, in the constant collision and condensation, a rock-like star is formed, and the Earth also inherits the rotation speed of the nebula. This is the origin of the speed of the Earth. It is not controlled by a certain force, but has been spinning since since the moment it was born. During this period, countless fragments and small stars were thrown out of the solar system or fell into the sun. Only those with just the right speed can survive to this day. The Earth is one of the survivors of this cruel erosion. It is the origin of the speed of the Earth that happens to reach a subtle balance with the sun so that it can safely revolve around the sun for 4.6 billion years and neither fly nor fall. And all of this seems to have been carefully filtered out by the universe. Because in the thousands of simulations of scientists, there is only one star on the Earth. Imagine how lucky the birth of the Earth is. According to the latest observational data, the Earth is moving 1.5 centimeters away from the sun every year. The main reason is related to the quality loss of the sun and tidal force. But we don't have to worry, because according to this speed calculation, the Earth will only move 1,500 kilometers away from the sun every year. This distance will not affect the Earth at all. And what we really need to worry about is the life of the sun. About 5 billion years later, the sun will enter the red giant star stage, and its volume will grow 200 times as it is now. Not only can it swallow up water stars and gold stars, the Earth will also be baked into a piece of clay. By then, even if the Earth is still revolving around the sun, it is no longer suitable for life to exist. And before that, humans can still live safely on this fast-flying planet and follow the sun at a speed of 220 kilometers per second to run wildly in the Milky Way. Every 2.26 billion years, they will return to the same position. This is not a miracle, but a physical law that truly exists. But it is these cold physical laws that give humans a warm home, so that we have the opportunity to look up at the sky and think about the ultimate mystery of the universe.